Hi guys, can you hear me?
Yes.
All right, we're just waiting a few minutes for Bernard to change from another meeting into this one, and then it should all work. Hi, Michaela.
Okay. Well, it worked in the end. Excellent.
All right, awesome. We're just waiting for Bernard. Give him a minute, and then we can start this.
Okay, sounds good.
Sabrina, where is the screen share? I'm not often using Zoom.
So the screen share should be just at the bottom of your page. It's a green symbol that says share screen. All right. So we are now broadcasting a live stream of the NASA stream on YouTube so that people can start watching, and then we're gonna kick this show off. We've had a few technical difficulties with the stream, so that's why Bernard is still in the other meeting, but I think he should be here shortly. All right, guys, Bernard is logging in right now, and then we're gonna start immediately. Okay. Clement, you have to, I think, allow him to come in. Okay, guys, I think we're all here. Dimitri is going to join us a bit later, I think, but he's one of the last presentations, so it should be all good. We can start now. We're live streaming, so everything is working. And all right, let's get this show started. Bernard, are you ready? Okay, maybe let's give him a few seconds to turn on his audio and everything. Bernard, can we start from your side?
Mm-hmm.
We are running a bit late. I think your internet connection is really bad. All right, everybody. I think we're going to start now. Is everybody ready? And then maybe Bernard can give his presentation a bit later. Are we okay? All right, then we can have Michaela start. Okay. Well, good morning, good afternoon, and good evening all around the world. Welcome to the EuroMoonMars live show in honor of the Perseverance Rover launch. I am Sabrina Kerber. I'm a space architect from Austria and an analog astronaut with EuroMoonMars in high seas. I am also your host for today's show. My co-host is Professor Bernard Foing, the director of the International Lunar Exploration Working Group, and also the senior scientist and father of the Smart 1 mission that took the European Space Agency to the moon. Today, however, we're going to look a bit farther. We're going to concentrate on Mars. Several space experts will tell us about their research and projects in the field of Mars exploration. And of course, we will watch the launch together and give live updates on the preparations. To start off, our first speaker will be Dr. Michaela Musilova, the director of High Seas as part of the International Moonbase Alliance. Michaela organizes and takes part herself in analog missions to the moon and Mars in Hawaii. She's also an astrobiologist from Slovakia who specializes in life in extreme environments. Michaela, thank you for making this work. I know it is very late on your side, so I won't delay any longer. Please tell us a bit about the Mars missions and also about the rover experiments that are done at High Seas.
All right, well, hi everyone, and aloha from Hawaii. Yeah, it's almost 1 a.m. here, so I think I'm going to give my presentation and probably head to bed. I was going to set an alarm for the launch, but at this rate I might as well just stay up. We'll see. I'll keep my presentation short, so let's hope that sharing my screen will work. Sabrina, if you could also confirm. There you go. You guys can see my presentation all right?
Yeah, all good.
Okay, great. Let's make it be full screen. That will work. Yes, there we go. Okay. So I think, well, once Bernard will be able to get around to it, he'll tell you more about the rover itself that's about to be launched to Mars. And so my presentation is more about what we, sorry, I don't know if it's moving by itself, about what we need to do on Earth in order to prepare for sending things to Mars, including not just rovers, but humans in the future. And that's why we use facilities like the High Seas Station in Hawaii to prepare for such future missions. I think, well, once Bernard will be able to get around to it, he'll tell you more about the rover itself. That's about to be launched.
So can you
so
please
the station you can see in the
stream
picture,
in
that's
the
the
back
High
because
Seas
we have a short
Station.
delay.
It's this white dome. It's located on the volcano Mauna Loa in Hawaii, and then it has another little building next to it, which is the engineering bay, which also has an airlock to go inside the station. And the inside of the station looks like this. Maybe the picture is misleading. It may look a bit bigger than it is in reality, but it's actually a very small place for those of you who are not familiar with it. The area you see in the middle of the picture is kind of main common area where you do everything from exercising, working, cooking, and socializing. And then you each get your little bedroom, which is in the picture on the top right, where people go and seek some privacy, though there are also many studies on how we should increase privacy during these missions, which perhaps maybe even Sabrina will talk about at some point. So this is just to give you an idea of when we train there as analog astronauts, what our environment looks like where we live. And this is an example of the kind of food that we eat. I always like to joke, if you look on the right-hand side, there's a picture of beef, and then, I don't know why this keeps doing that, picture of what freeze-dried beef looks like, and underneath is a picture of what freeze-dried chicken looks like. And essentially, it doesn't taste very different one from the other. Essentially, the color is the main difference. So you need to be lucky and have a good cook on the crew who can make even this freeze-dried food that looks and tastes like dog food sometimes, tastes like something more similar to what we have on Earth. It also comes in forms of powder, and you can get all sorts of freeze-dried vegetables and fruits and things, which are some of the nicer things you can eat on missions. And then we are supported by a mission control center. You can actually see Bernard in the picture on the bottom right. And I'm in the picture on the top left. That's when people who are flight directors and mission support help the crews during the missions from Earth. If it's a Mars mission, then there can be up to a 20-minute delay in communications each way. So even in an emergency, it would take over 40 minutes for help to come from Earth. So people on missions have to be trained to be very autonomous and solve problems on their own. And then we also many times have remote support by volunteers all around the world, including people in Europe, for example, at ESTEC, and many members that are currently going to be giving presentations shortly. And in terms of the research, we do a number of different types of research during the missions, all relevant to space exploration of the Moon and Mars. So here in these pictures, you can see some lava tube exploration, where we do geology research, astrobiology research. Then we do some human factors research, such as psychology, sociology, and things like that. So you can see in the top left picture, crew members being studied for how their mood changes depending on the activities that we do together. And in the bottom right picture, you can see some research related to physical exercise and how that influences let's say the happiness of the different crew members and also social interactions. And then we do technology testing as well, which is very relevant to today's mission that's about to be launched to Mars. You also have to test rovers and other technologies on Earth first before you want to attempt to send them into space. So in this picture, you can see 3 different types of rovers that we tested on a recent mission at high seas this year. And then we also had a little drone you can see in the picture as well, which in a way you could say is somewhat equivalent to the Mars helicopter that's going to be launched later today. And then we also used much bigger rovers like this one you can see in the picture, essentially the size of me who's on the picture next to it. And these rovers in particular were tested for their ability, again, apologies, I don't know why it keeps on doing that, for their ability to move around this difficult analog lunar and Martian terrain. Many of them have different sensors and cameras on them, so we test how well they work and respond under these conditions. Also, these rovers can be communicated with remotely and operated. So many times, for instance, this rover you can see in the picture was actually remotely operated from inside the habitat, and the astronauts outside were actually only making sure that it wasn't getting damaged and that it was being operated correctly. So different types of experiments can be done on the rovers, and I will show you now to wrap up my presentation, a video made by a Slovak company, Robotech Vision, who tested one of their rovers during a recent mission on the moon in collaboration with the EuroMoonMars group. And the purpose of those rover field tests were to see whether it can operate in very sharp volcanic terrain, which you will hopefully see in the video. So not this kind of smooth surface you can see in this picture, but actually some very steep slopes and sharp rocks. And we were also testing, again, navigating it from inside the habitat, so not by the analog astronauts in the field. And in the future, we're planning on attaching different sensors and devices to it, as we have many of the real rovers on Mars today, for example. So here's the video. I hope that it will work for you. Don't worry so much about the sound. That's kind of just background music. So those pictures were actually taken by the drone that you saw in the previous picture. And yes, shortly you'll see the rover go into much more challenging volcanic terrain, and actually I do it pretty successfully. This one was particularly impressive. I was climbing up this. pretty sharp slope or steep slope and sharp rocks. And again, the whole time it was operated from the dome, from inside. So the people inside didn't actually see anything. Everything they used was this camera, which you can see now. This is the camera attached to the rover. They only had this view and they were able to operate the rover remotely throughout the terrain. And we were just essentially chaperoning it outside to make sure it didn't get damaged. Okay, so that was a very, very quick introduction to what we do at the High Seas Station, different types of research and technology testing. If you would like to know more, please don't hesitate to get in touch. Here are my contact details. And also we are recruiting for analog astronauts on missions at High Seas. So please get in touch if you'd be interested in that or to collaborate on research projects. Thank you very much for your attention.
Okay. So excellent, Michaela. So we have 47 minutes, 42 seconds to launch. So yes.
Ooh, okay.
Okay, so it's coming.
Let me figure out how to stop sharing. There we go. Okay.
Okay, thank you for that presentation, and also thank you for making it work this late. I don't know if you're going to stay with us or go to bed and then come back to watch the launch. Do whatever you feel comfortable with. We are really grateful to have you tonight.
Oh, no problem. I'm happy to answer any questions if there are any now. But yeah, then I will log off and probably follow it all from my phone.
Yeah, so okay, we hope to come and see you soon. At the moment, we are looking to organize a EuroMoonMars campaign in November, December, and also possibly next year. So we have to adapt to some of the current conditions of traveling between Europe and US. But we will overcome. You know, we have a lot of perseverance and in all what we do with the International Moon Base Alliance and with ICES and EuroMoonMars. So, okay, we are looking forward to go there and also to see you there here in Europe, Michaela.
Thank you so much. And yeah, I really hope that it'll work out. You know, pandemic has made things difficult for everyone, but I'm sure we'll find a way. So yeah, let's keep going.
I'm sure we will. And if any of our viewers have questions about Michaela's presentation or any of the presentations that are going to come, you can post on YouTube, and we can also collect the questions and direct them to the speakers if they have to log off earlier. So there's always a way to stay in touch with us.
Good. Oh, sorry, I was interrupted. There was a huge sound here. It was not the sound of the rocket to be launched because it will be only in 45 minutes. But yeah, so just in short, before we go to analog presentation, just to recall you, yeah, what perseverance is. Is that good for you, Sabrina?
Yes,
yeah.
Please tell us a bit about what we can expect.
Yeah. So clearly, we will, perseverance is the spirit of exploration. So with a stronger American component, and you will see that in all the materials that NASA is distributing. So the pillar 2 of perseverance is to launch a rover that is building on the technology that has been tested in previous mission. So we had before the Mars exploration rovers. You know, they were launched in 2003. Spirit and Opportunity, they were quite long-lived, and they have made already a large exploration of what were the conditions on Mars, in particular, what was the past history of water. And in Perseverance built on some of the technologies, you know, in particular for landing, it is using a similar system that was used on Curiosity. So a system where you are using a crane, so a kind of mother crane, like this bird, that is delivering the baby on a rope and then fly away, not to achieve soft landing, but also not to perturb the site where the rover is going to land. So it will be landing in a place that has high potential for finding signs of past microbial life. So, and in particular, that's a J0 crater. And in this J0 crater, which is about 45 kilometers wide, there is some very great signature of a delta. And I think Dimitri is going to unveil some beautiful new data from Mars Express, because, you know, in Europe, we are part of this large Mars exploration adventure, and we share data. And we have beautiful data from Mars Express that Dimitri is going to show us. Scoop for today. Now, Perseverance is going to also obtain data on the geology of the place and also on the climate to see what is the environment where this putative life in the past could have been developed, could have been also emplaced. Now, properly, Perseverance is not equipped with the best instrument really to search for ancient life. So you will see that on the US media. Yes, we look for life with Perseverance. It's just a first step. So we are looking mostly with Perseverance as measuring with some instruments. So there will be a camera, mass cam, there are instruments also shooting a laser at rocks and the soil to determine the elemental composition. There is an oxidation instrument. There is also a fluorescence X-ray instrument. There is a number of instruments, mostly to characterize the condition of the soil, but we are not completely equipped to search for life there. Two reasons. First, this requires new instrument that must detect very small quantities of organics. And second, life on the very surface may not have survived over a billion of years. So for this, you better go in the depths. This is what we discussed later with some mission like ExoMars. But for sure, Perseverance is a key component in the search for life because it's the first step in the round trip to Mars. And we have discussed NASA and ESA and other international partners to also be able to get some of the sample from Perseverance, put them in some beer with this life. We cannot bring Earth life there. We cannot bring Mars life back to the Earth. So we have to be very, very careful. But clearly, this is also on the way to prepare the future humans around Mars. So that in brief, what Perseverance is about. And some of the research we are conducting is very much in support of those objectives.
Awesome. Thank you for that information about today's launch. And I think we'll just quickly keep going on to our next guest speaker, who is Annelotte Werth, and she is actually one of our EuroMoonMars analog astronauts at HISEAS.
The rocks I studied at Hawaii, and the orbiters around Mars have found some iron magnesium smectites, which are alteration products of this type of basement. And I think I also have found them at Hawaii, but I will tell you a bit more about that in a minute. So with what instruments can we find these clays on Mars? Well, first the XRF spectrometer Bernard was talking about, the pixel, this one. It can measure the bulk chemistry of a rock, so it can also say something about whether or not there are clays present in the sample. Then there is a SuperChem, which is an updated version of the ChemChem, which can also measure the mineral composition, also clays. And there is a Sherlock equipped on the Rover, which is a Raman spectrometer, which can also measure minerals and mineral spectra, including clay spectra. And furthermore, there is a seismometer, which can measure or detect some interesting features underground, but this is not related to clays. There's a set of sensors which can measure some climate characteristics. There's a device which is going to try to turn Martian CO2 into oxygen in case of, for the future possible Martian settlement. So it's important to do some experiments on that. And there is also an imaging device. Then we go to the research I did at Hawaii, these rocks at Hawaii, they are way more younger than the ones we find on Mars, and therefore you can study the alteration process better, and the outcome you can compare to Martian rocks. So here on the left we see a really young lava flow, which is still really nice and shiny. You can see it here on the top of the flow. When we look to an older lava flow, we can see the shiny top layer has disappeared. This is due to participation on Earth, which is a little acid and removes the shiny layer. And when we look to much older lava flows, we can see a brown alteration layer on top, which is made of clays. And if we look to even older lava flows, then the brown layer we see here on top becomes even thicker. Then I can show you some preliminary results of the rocks. Here we see some of the samples I took, and this is the left one is a sample of this really young flow. Below we see results of infrared spectroscopy I did on the rocks, and the blue dots represent clays present in the samples. We see that on this left sample there are almost no clays present in the rock because there hasn't been much alteration. But if we look to older samples, we see the blue dots increase, and there are more and more clays present within these rocks. So yeah, I'm still processing all the data. So yeah, it's going to be continued, and I think this is also the case for the rover. So I'm very excited to the first results, and yeah, thank you.
Thank you, Annelotte. That was very interesting. So how many samples did you take during high seas?
Well, I took a bunch, but I only took home 13 samples. So yeah, not really much, but it's also quite a way to travel from Hawaii to Europe.
Yeah. I see Bernard is timing the launch.
Yes, 32 minutes, 43 seconds to launch. So we are still on time. So it's also in our schedule of talk. So I think we have a good coordination so far.
Okay, yeah. That's all good. Bernard, is there a question for Annelotte from your side, or should we move on to our next speaker?
Yes, the question also, actually, we, during the pandemics, we had to move out of ESTEC. And I could recover some instrument from ESTEC, like an infrared spectrometer, visible spectrometer, Raman, and we were able to install it in one of my offices in EuroMoonMars laboratory that I've installed close to in my home, in the other home. And we had another student, Marjolaine Data from Free University Amsterdam. She has started to analyze some of the samples, including some samples from Annelotte. So,
okay.
Yes, so we have made a comparison between infrared spectra of sample from Hawaii, from Iceland, also from Utah as well.
Okay.
So we will continue, and we hope also to to continue some of this work of analyzing the effect of billion of years of water on Mars that is equivalent to only 1,000 of years on Earth, and help also to interpret some of the data for the rover and the orbiter.
Okay, yeah, I guess it's good to share samples and collaborate on projects. And this actually brings us to our next speaker, who is Francesco Ventre from Italy. I hope I'm pronouncing this right. He's currently finishing his master's in space engineering at the Politecnico di Milano, and also is the co-founder of the startup Volley Mobility, which aims to establish a taxi drone service in Italy. Francesco will talk about a feasibility study that was also done in a collaboration with many team partners. And it's a study for a mission to the Martian South Pole. Francesco, can you tell us a bit more about your project?
Yeah, sure. Let me just share my screen. Okay, can you see it?
Yes.
Okay, just one second. Okay, so here we are. I'm Francesco, as Sabine said, so I'm here to present a highlight of the Mars Penguin mission, which is aimed to explore the south polar Mars. Just let me close the. Sorry. Okay, so the main goal of the mission was to analyze the icy soil over a subglacial lake, collecting samples of the icy crust. Another objective is to observe and characterize the geyser phenomena that happen during the southern polar spring. This operation on the planet should last at least 30 months and the departure is fixed after 2024 as the customer requires. So the geyser eruptions are phenomena occurring at the beginning of the spring when the solar radiation increases and the CO2 ice formed during winter starts sublimating and increase the pressure under the soil and cause kind of explosion. So this eruption deposits on ground some materials of the underneath soil in the dark spots that you can see in the image in form of spider webs. And this allows to identify the geyser sites. Let's now go through the overall configuration of spacecraft. So on the left, you can see the assembly of the spacecraft, composed by the entry capsule, which contains the sky crane attached to the stowed rover. And so the capsule is obviously linked to the free stage. The descent module is composed by two segments, the sky crane and the entry capsule. The design of the entry capsule was a critical aspect of our mission. And so for the back shell, a triconic shape design has been selected. While regarding the sky crane, you can see in the bottom right, its central shape is hexagonal, which is particularly good for this element since four sides are elongated in order to provide support to the thrusters. This sky crane will be connected to the rover by means of four legs. The launch is scheduled for 23rd of 2028. So after 10 months of cruise, the spacecraft will reach Mars and land on it on September 2029, a time at which it will be spring on the southern pole of the planet. The entry, descent, and landing phase is crucial and must follow a precise sequence of operation that will be explained later. So the analysis around the lake region will be carried out till the beginning of summer, when the rover called Skipper will start its travel toward the geyser location. So this travel will last a maximum 3 months. And once arrived, the rover will start its operation and will be put in sleep mode to survive the Martian winter. With the beginning of the spring, rover will be waking up and we start to observe the geyser phenomena assisted by the helicopter till their disposal that will happen after March 2032. So the overall EDL trajectory can be divided in three main phases. The first that goes from the entry up to departure deployment, the second one to the back shell detachment, and the final propulsive phase performed by the sky crane. A ballistic trajectory was chosen so that the angle of attack of the capsule was considered to be equal to 0 throughout the trajectory. During the parachute phase, its shield is jetted onto a spring mechanism. Then the parachute keeps decreasing the capsule velocity until the back shell detachment at the 1.6 km from the soil when the spinal sky crane propulsive phase starts. It consists in a constant velocity descent in order to safely deploy the rover on the surface through an 8-meter-long bridle. Finally, the sky crane performs a flyaway maneuver in order to impart the soil at a safe distance from the rover. Now that we know how the landing will be performed, we can focus on the ground operations that are the core of our mission. Skipper is divided, which is the rover, is divided into two separate modules that you can see in the figure on the right, a scientific module and a service module. First is characterized by two sections, an upper zone where the electronic boxes and a bottom part that will be an ultra clean zone with the actual laboratory for sample analysis you can see on the left. When the drill and the robotic arm collect samples, they will pass through the sample handling and distribution systems that delivers them to the scientific laboratory by means of carousel. So two different instruments will sample the two regions of interest, so the lake and geyser. The first is the drill for sampling the acid soil above the subglacial lake, and it has to dig the polarized soil for 1 meter and will work in spring after the landing. It will be lower from the rover body to the ground level in order to reach maximum depth. The second instrument for the geyser reject sampling is a carbon fiber robotic arm with 4 degrees of freedom that will allow to dig and bring material up to the scientific laboratory. This instrument is equipped with an X-ray spectrometer to select the best sampling region. In case of drill failure or stuck, it can be released by the rover, and Soldato could also collect samples in the wreck region in order to fulfill, in any case, those sampling requirements. For the sizing of locomotion system, we relied on Becker theory, and we consider a rigid wheel. So we have a 6-wheel configuration, since this is a good configuration in terms of stable negotiation. In fact, it allows to have a rocker body suspension, which is the most suitable suspension for long travel on uneven terrain. About the navigation, we actually performed a Monte Carlo analysis to evaluate the landing ellipse, as you can see on the left, and that was crucial to define the needed accuracy of some ideal driving variables. The wall ellipse has a dimension compatible with the lake that has a maximum one of 20 kilometers. So the design of skipper locomotion system is based on the travel path you can see on the left to reach the nearest geyser location, which is about 27 kilometers. In order to cover this distance in a reasonable time, we set the regime speed to 0.1 meter per second with a traveling time of 4 hours per soul. This will allow skipper to cover 50 kilometers in 35 souls. So a few words about the helicopter. So a secondary area vehicle will support the rover in the operation on Mars. It will be released by a skipper in the geyser region to help the rover in the observation and study of the geyser. Moreover, the helicopter will help the skipper in navigation, providing better images on the ground. Kowalski accomplishes the job using 2 cameras, one for optical navigation and other one for science imaging. As you can see in the figure on the right, the release mechanism of Kowalski is a bottom panel that will allow the helicopter to release to deploy its legs. So Kowalski will be powered by means of vertical solar panels and 4 secondary batteries. And the panel will be vertical since the sun's south pole is very low above the horizon. In order to grant the proper temperature ranges, passive thermal control has been used with silver surface finish and 2 radioisotope heat units. So let's go to the design mission. The South Pole Mars has been a challenging but exciting experience, and to meet the requirements of the mission, for sure there will be needed some improvement in the technology readiness level, and we hope that realizing such mission will lead to discovery of extraterrestrial life and eventual water resources, paving the road for future Martian settlements. If you are interested and you need further information, feel free to contact us, and thank you for your attention.
Thank you, Francesco. I have one question about the next steps that you showed us. Do you have a bit of a timeline for that? So what's coming up next for you right now?
So actually, yes, as you can see, you can't see anymore. Okay, yes, maybe now you can see again. Okay, we have like a timeline here. Basically, we need to improve the computer capabilities. So also the helicopter will need a little bit of development, because for example, now Perseverance will release its ingenuity on the surface of Mars, but it's still a proof of concept. So anything should be customized to accomplish its task. No? So we will need some improvements, and this is basically a preliminary yeah, preliminary study of the mission. So for sure there will be needed a more refined model to better characterize the mission. Yes.
Okay, thank you.
Thank you.
Bernard, are we still okay with the launch? What's happening with the launch? I think you have muted yourself.
Okay, yeah. Yes, we are 20 minutes to launch. So we will have a talk from Dima, but before, let's say where we are with all launches to Mars. This is the year of Mars today. 2020, we will always remember positively that a year where we launched many probes to Mars. We'll forget about COVID and all these things. And actually, already on 17th of July, we had a mission called Al-Amal, which is in fact hope in Arabic, which was launched from Japan with the H-2A rocket by the United Arab Emirates. So that's a mission which is focused on having instruments to study the upper atmosphere of Mars, in particular the escape of hydrogen and oxygen from Mars, something that follows a bit what Mars Express has done with Aspera that Dima will be recalling us. And this will go on an orbit 20,000 by 40,000 kilometers, mostly to study the day-night cycle around Mars. And after 7 months travel, it will arrive in February 2021. And this is the 50 years anniversary of the UAE. So they will make a big party. And then we will have operation for at least 1 Martian year. But that's not all. Also, on the 23rd of July, China launched their first rover and orbiter lander to Mars. It's called Tianwen-1, which means questions to heaven. And so with this orbiter, we have 6 instruments, cameras, spectrometer, magnetometer, radar, particle analyzer, and also a data relay to send the data from a rover to Earth. And the rover is a 240 kilogram vehicle. It will last 90 sols. And it has also 6 instruments, in particular, a ground penetrating radar that is able to penetrate 100 meters to the depths of Mars. And that's the same technology that they have used on their Chang'e 4 rover on the far side of the moon. And it has also cameras, magnetic measurement, meteo, dust, and they have also a LIPS instrument, so an instrument that shoots a laser at rocks and soil, produce a gas that they analyze to obtain the elemental composition. And they plan to land in Utopia Planitia. Now this is a place which is well known, an impact basin where Viking 2 landed in 1976. And in this place, there are some special topography that indicates that in the subsurface, you do have some deposit of ice layers, even at a tropical altitude. And so that will be also very interesting to see from that what was the ancient history of water and ice on Mars. Last but not least, we have also towards the future ExoMars 2022. Actually, we were supposed to launch it this month too, but okay, it was postponed to 2022. We will have more opportunity to talk about it later after the launch. But this is to bring lander and with an entry descent landing module, a landing station, which is mostly provided by our Roscosmos friend and colleague, and a rover of 300 kilograms to search for signs of extinct and extant life, in particular with a drill that will go to 2 meters, where this life could have survived. But we will talk more about ExoMars because we have only 16 minutes left. And so I pass you back the word.
Okay, thank you. So it sounds like it's going to be crowded on the Mars. There's a lot going on, and this is the perfect opportunity to hear from our next speaker. This will be Dr. Dimitri Titov, the Vice Chair of Commission C of COSPAR and also a staff scientist at ESA's ESTEC facility. He was involved in a great number of space projects, many of which focused on Mars, and since 2015, he's the project scientist of ESA's Mars Express mission, about which he will be telling us some, giving us some information about now. Thank you for joining us today.
15 minutes to launch.
Perfect. If I could ask our tech support to please unmute Dr. Titov, so that we can hear.
Mute.
Thank you. Oh no, Dr. Titov, you are still muted.
Yes. Okay.
Right.
Yeah, good morning. Can you hear me?
Yes.
Okay, and can you see the slides?
We can see everything, yes.
Okay, good afternoon and good morning, good evening, depending on the planet which you are now. So I will briefly tell you about the Mars Express story because we have not so much time. So, and as you see on the first slide, 16 years of hard work. This is the time that Mars Express was in space around Mars. 16 years is basically the teenager time, but teenager age, but for a spacecraft, it's pretty mature state. So that's why Mars Express did a lots of nice work at the planet. And let me see. Yes, okay, I can. Can you see another slide? Because
we can see to the right in a small version of the slide.
Yeah, this is strange because I cannot, let me see, resume slideshow. It's a bit strange.
I think you're in presenter view. If you go to the top left of your screen, you can press on display settings and put it.
Yeah, so that's, I know all these, but now it's a strange mode. Yeah, let me see display settings, duplicate slideshow. I think that this should be better now. Okay, can you see that?
No.
It hasn't really changed.
Maybe stop the screen share for a moment and restart.
Your screen share is post, stop share. Okay, boom. Okay, so I'll start again. So can you see my screen now?
No, we can't, unfortunately.
Mm.
There should be a green button below the big picture.
No, well, I just see Zoom, but I cannot. Well, I do not see anything. How can I? So it's strange. I do not have the Zoom screen where I can do all this share and.
How did you manage to share it in the first place?
Yeah, at that time I saw the Zoom screen, but now I see nothing. Okay, start Zoom. No. Okay, good. So then let me see.
You can also try the shortcut ALT and S.
No, I think that, okay, share screen now.
Okay, yes.
Yeah, okay.
You have now, yeah. All right, sorry about this.
Okay, 11 minutes to launch.
Yeah, okay, so let me go quicker. So Mars Express, indeed, it was designed to address many goals at Mars, and you see the formula is a comprehensive study of the surface, atmosphere, and plasma environment in space and time. So, and these are different areas for which we can study Mars. In which we can study Mars's geology, weather and climate, atmospheric escape, and phobos. So then if I go further, these are the examples of how Mars Express is revealing geological and historical aspects of the red planet. So here you see really stunning images which we're getting regularly from the orbit. Those are the color images in stereo and resolution of about 10 meters per pixel. So this is a regional scale. And here you see, for instance, that there is a lot of nicely visible old flows of water, then the canyon, then the crater which is filled with ice. We can also look at the polar cap, and with the radar we can penetrate deeper, and here you see the slice of the polar cap. So basically you can penetrate down to the basement of the polar cap. And what is important also, we can create the global maps of hydrated minerals and different other minerals. So this means that we can reconstruct the history and evolution of the surface, because hydrated minerals, they mean that there was, some time ago, there was water there. So when looking at those places, we can really see where water was flowing on the surface. So the next slide shows you really very colored but probably poorly understood picture. This is the record of observations of weather and climate with Mars Express. And what you see, you can take it not as a scientific picture, but for instance, some kind of Vasily Kandinsky imagination. So, but basically all the colors here, so they show you different properties of the atmosphere, like temperature, like water component, dust. And the color here means the abundance of all these components, separated by vertical lines, which are different years. So basically for 7 Martian years, Mars Express was looking at the weather and looking at the changing climate and weather. Also, we know that there was water once on Mars, but where did it go? And with Mars Express, we managed to look at the plasma around Mars. And here you see the cross-section of the plasma. If you imagine that the sun is on the right from this picture, and the solar wind is blowing the material from the planet, and in the wake of the planet, you see the red, which means escaping hydrogen and oxygen atoms. So all these things are really key discoveries of Mars Express, and there's lots of detailed stories about this, so we cannot really go into detail. Now, interesting that we are not alone. I mean, from European side, we also have the ESA Roscosmos Trace Gas Orbiter, which is working with us in orbit. And we are doing the joint and coordinated measurements of the Martian atmosphere and the surface. Well, the next slide shows you the landing sites of Mars missions, and you see that indeed it's becoming crowded on Mars. So the Perseverance rover will be landed here on the side of Euclides Basin. And you see this is really the nice place where the border between the highlands and the lowlands, which were originally lakes or oceans even probably. And I will just try to show you the movie which was just released by it's cannot playing the movie. I don't know. Okay, so then probably I will stop here. And really Mars Express is eagerly waiting for the Perseverance rover to come to Mars, because we're planning to work together with this spacecraft. Thank you very much.
Excellent. We can play after the launch eventually. That would be good. Would be good. Yeah.
All right. Do we have time for one question, Bernard, or should we switch to the live stream?
Yeah. So, how do you support directly Perseverance? So with images, and also there are other support functions that you can provide?
Yes, well, first of all, the characterization of landing site was done with the images from Mars Express, and of course from other missions as well. So we're working together. We are doing also, as usual, support for crucial operations from the European Space Agency helping NASA in crucial operations. This is a usual program. We are helping each other. And I suppose that also with downlink, we will be able to help.
Yeah, like backup data relay, doing critical.
Yes.
Excellent. So let's move to the launch pad then.
All right. So we'll show some live footage from the NASA stream right now, and Bernard can just tell us what's happening.
Yes. Okay. So if you should have, yeah. So we see the rocket on the launch pad, and okay. Of course, it's a critical moment. Is all the preparation towards the launch? Yes. And after this, it's not done because this is quite a complex operation to send a probe to Mars. So you have this special rocket. It has various stages. The lower stage is a solid booster. And then you have some, this is going to be used for about 1 minute 52 seconds. And then it will be jettisoned. And then you have the second stage that will be able to reach Earth's orbit. But after this, you need also to go to Mars. And that's also a very critical operation. For this, there are some kick-off stage that has to burn twice. And typically, it has to burn about 6 minutes. And then it will be on a coastal orbit. And then it will have to reburn again. And this will be the stage to send the probe in interplanetary space towards Mars. That's a very critical phase. In a few past missions, this phase didn't work well. So I think that this success is not only right after launch. We will have to wait at least about 1 hour to be sure that everything is sent towards Mars. And also we'll have to check that the systems are operational after they have been launched. So maybe there is some, okay, so you can see the launch pad and in Cape Canaveral is a special launch pad. Yes, so that's everything is operational. So as you see, there are always for this launch, there are a series of checks that have been done on all launch subsystems, also ground support system holding the launchers and also the spacecraft. And also there are checks on weather locally, also weather on the trajectory that the launcher is going to encounter. And here you can see the beautiful clear day. It was already suspected, 80% chance a few days ago. So that's another view from nice cameras, some of the small cameras that they put on top of the rocket. You can see some of the cooling gas that is maintaining some reservoir at the right temperature. So maybe, yes, yeah, I mean, some of us had the chance to see some Mars launches in the past. And I think that Dima, I suppose I've been able to, to see some of that also. But this was, for instance, Mars Express, it was launched from Kazakhstan, from Baikonur. But here, that's from Cape Canaveral. Launches. So maybe do we have the sound as well from the NASA the NASA TV channel? You see, we don't want also to miss the roar of the rocket when it will be launched. Do we have this?
I think we actually only have the subtitles because we're streaming live on YouTube. So I don't know. We can see if our tech support can manage to.
Okay, let's see if I have the sound. Okay, so okay, so and you can see also the discussion that they have actually. This is Roger. That's what we use in our simulation to acknowledge that we understood the command. That's all fine. So 18 seconds. So let's see. That's okay. So now, yeah, excellent. So a little wind. Yeah. Okay, so there was a. Okay, so 27 to 0. Final go. And so that's an Atlas Centaur rocket, huh? The one with a solid rocket booster. This is on the bottom. This you can just switch on and. Yes, we got the sound exactly at the right time. Put your video on. Excellent. So they monitor the performance of the engine. Now the solid rocket booster. Yeah, after 1 minute, that's when they have the biggest stress on the whole structure. Dynamic pressure. Okay, so yes, now in about less than 30 seconds, we should have the separation, so jettisoning of the solid rocket booster. Okay, so they all burn out the 4 solid rocket booster, and they will be just get rid of jettisoned. Up, you see them being separated. We have a good indication of SRB jettison of all 4 SRBs, and the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. Okay, so the trajectory is nominal, the right path and the right attitude, which is also important. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. So now the second stage is taking all the effort to reach orbital speed around Earth. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload bearing jettison. Engine response and vehicle acceleration look good. Yes, they keep the load acceleration variable for all the payload that we have on board. And we have good indication of payload pairing jettison and Centaur forward load reactor deck jettison.
and the RD-180 is throttling back up to attain a 4.6G acceleration.
Yeah.
Engine response continues to look good.
Yeah, so they also eject the coiffe, we say in French, or the fairing on top of the rocket that was protecting the spacecraft during atmospheric ascent.
Thermally condition the RL-10 for operation. Standing by for BECO shortly. BECO is the call for booster engine. And we have BECO, booster engine cutoff, standing by for stage separation.
So these are the liquid engine. Huh?
Atlas Centaur separation. So they're using live footage, and we have the Mach 1.
Okay.
RL-10 operating parameters look good. Chamber pressures are stable.
Okay. So you see, they have also cameras that can monitor the exhaust of the rocket. That is also controlled in orientation.
7 minutes in length.
Okay, so as I mentioned,
that's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here.
So yes, the rocket has escaped Earth's surface. It's still in orbit around the Earth. And the next critical phase is to be able to go in an interplanetary trajectory. So for this, you will have two burns, a first burn of 7 minutes. And then there will be a coast phase of about 20 minutes, where they will require the exact trajectory and also that optimize, in fact, the energy you spent to go towards Mars. And then you will have another burn of 6-7 minutes that will inject it in a good interplanetary orbit towards Mars in the right direction.
Amazing, that looked really cool. So Bernard, do you think we can go on with our presentations?
Yes, let's say, because actually now we don't have live data, we have just a trajectory. And so we will monitor that the trajectory is nominal and that the systems are nominal, but everything looks fine. So let's go back to our presentation.
Okay, because I think now that we have sent the rover on its way to Mars, it is a good time to talk about what might happen if we don't send only rovers, but humans to Mars. And this is why we have Gilles Schneider join us. He's an architecture student from Luxembourg who is currently studying at the TU Vienna in Austria. He recently worked on a design studio on the topic of the Mars Science City, and he will now present us a future vision of space travel and a proposal of what living on Mars could look like.
So, hi everybody. I hope you can see me and hear me.
Yeah. Hello from Mars.
Yeah, let's dive right into this. So my project partner and Armin and I have a vision which comes down to full freedom of movement in outer space. So this semester we were asking ourselves, how do we get closer to this vision? So bottom up, we decided to make Mars a connected planet by building a rover that can offer a means of transport for humans as well as cargo. So you should imagine Mars being inhabited by numerous space agencies, which will establish cities all over the Martian surface by time. To most efficiently work together, you will need to have a form of communication between those habitats. So that is where our Mars rover comes in. So let me introduce you to the rover. On the left side, you can see the rover with its wings opened up and deployables folded out. So compared to the right side, where the rover is shown all closed and back into its original mold. So we use a foldable structure to increase the volume of payload you can take with you in order to transport a handful of people or a useful amount of cargo. Modules adapted to the various needs can be attached to the rover. More precise, they can be attached inside the foldables. So that way we can talk about 3 different stages that the rover can be in. So we have got here 3 top views on the rover on your right side. So if we start with the bottom drawing, stage 1, the rover's wings are, the rover's wings are in its original mold. The foldables are folded in. So that way you can move at a high speed. If your 2 people are inside this rover, they can move very fast. If you're at a habitat, that's stage 2, you can dock onto that habitat and receive, for example, a storage module to bring it to another Martian city. And in stage 3, we have the rover moving these modules with its cargo or people inside around on Mars. But there is a bit more to the docking station. Let's have a look on how it works. So this is a top view, schematic drawing of the rover, which docks to the habitat. So when the rover docks its foldable to the habitat, the foldable gets pressurized. That way, whoever is inside the rover can move freely around without the need of wearing a spacesuit. And as well, in the docking phase, the fuel cells are getting charged too. So the rover has an energy storage capacity, which will ensure a chargeless running time of about 2 to 4 days, hopefully. But you may be asking yourself, what are even the benefits of this shaped rover? So due to its form and mechanics, it can adapt its wings to almost any uneven ground by lowering its wings to the terrain and therefore travel at the faster speeds. And should the rover ever get stuck, it can flip its wings about 180 degrees around and crawl its way back to more even ground. And my favorite part of it is it can serve as a movable research station on Mars missions to increase our progress of understanding the Martian surface. So this is an axonometric view of the rover's attached modules. This could be a configuration for a research mission with a living module for 2 people on the left and the laboratory module on the right, equipped for small experiments on the way. So to finish up, let me show you an image on how our rover could look like next to your Martian city. So I want to thank you all for tuning in. This is Moving Mars, and thank you for your attention.
Very nice. Can I ask you, so for how long can humans stay in that rover? What's the longest duration mission that you plan with it?
Well, to go from A to B, we planned like the capacity of the fuel cells to work 2 to 4 days. But if you go on a longer mission, you also have solar panels that you can fold out. And we hope that we can do like missions for about 1 month time as a research station outside on Mars. Yeah.
Mm-hmm. Okay, that's really interesting. And what are you doing for radiation shielding on such a long mission? I think it's probably integrated in the main part of the rover, or?
Yes, it should be integrated in the main part. We didn't go that far into it right now, but yeah, it would have to be integrated in it. It could be possible to also have to wear like a spacesuit if you're like going really, if you're gonna take a longer mission. But let's hope that we don't have to do this.
All right, yeah, cool. Thank you for joining us today. Bernard, do we have any updates from the rocket?
Yeah, I think the first boost is ongoing well. I was thinking that we have also still 5 minutes before the next talk. We have the J0 creator ESA Mars Express movie. It's available on YouTube. We could also just show that on YouTube, or do you want to, Dima, and then you could comment on it?
Yes, Bernard. Actually, this was the movie that I could not show for technical reasons. So now I understood why. But okay, so if you can show it, or
so Clémence, could you just Google the YouTube?
I can share the screen. I suppose that.
Oh, you have it already. You have it.
I suppose that I can do it right now. If can you see? Just a second. Duplicates I show. So can you see my screen?
Not yet.
No, for some reason it doesn't run again.
Okay, so let's see if I get it, because it's just the latest. If you Google Perseverance ESA Mars Express, we got this. Let's see. Okay, so Clémence, can you do that? And then when you're ready, you can call us. Otherwise, we do G0 ESA.
Sorry, if you see my screen.
No, we can only see the video.
No, you should see the video. Yeah.
Yeah, but only the video of you. So.
Oh, the video of me. Oh God, so that's, yeah, something is wrong with because really I tried to do it. I apologize.
Yeah. So eventually, yeah, Clémence, could you just directly show the YouTube of this J0 creator? Oh yeah, okay.
I think we have it right now. All right.
We got it.
Okay.
Excellent. Okay. So if you want to comment on it, Dima, yeah.
Yes. Okay, so this is the video which was made by the HREC, by the camera team working in Freie University in Berlin, and basically it's based on the images from the high-resolution stereo camera. And so here you see the crater itself, and you see the yellowish oval here. This is the landing site of Perseverance rover. And you see that this site is right in the estuarium of the old ancient river. So basically it means that there was a lots of material collected here coming from the highlands on the left side now. And so this is the place where the rover will be collecting samples, and then they will store the samples waiting for other mission to come and pick them up.
So we are flying over the place.
Yeah, well, it's really a conversion of the images into the video. So when you have images, you can create the digital elevation model of the terrain, and then you can really look at this terrain from any direction with the computer. But basis of this movie is real images from Mars Express.
Yeah. And here we have a little call for all of you gurus that are can play with this type of three-dimensional data. We are looking for a data visualization guru in the EuroMoonMars team, somebody that could take data from Mars Express, MRO, also from a lunar mission, and be able to make some of this visualization in 3D, even for virtual reality. So if you have these skills, please contact us at the EuroMoonMars team.
We actually also have another call for workshops that we are going to host at EuroMoonMars. So if you want to know more about them, or make sure that you get a spot in our workshops, because of course we have to restrict participations because of COVID-19, you can follow us on our social media. We have posted them below the YouTube stream. And then we will just tell you more about when to register for the workshops. We have two really interesting workshops coming up. One on September 12th and 13th at the Leiden Observatory in the Netherlands.
The old observatory, so it will be beautiful with telescopes.
Yeah, so this is going to be really interesting if you're interested in more the astronomy side of things. If you're more into space architecture and habitats, you could join our habitat workshop in Vienna on September 19. And this is happening actually a day after a super interesting conference, the Galaxy Forum, where we'll also have quite a few EuroMoonMars speakers. So you are welcome to apply for all of these opportunities, and please follow us on our channels so that we can connect and keep you aware of opportunities.
Good. Good. So let's see on NASA TV anything that they have to show. Otherwise, after this, we can move on to to Sebastian.
I think it's a good time to move on to Sebastian. Yes.
Okay.
So Sebastian is a geologist and geochemist from the VU Amsterdam, and he's focused on planetary studies in the field of geology. He bases his research on Mars analogs. So he's one of our EMI's analog astronauts, actually. And he was together on a mission with Annelotte. Sebastian, can you tell us a bit about your work?
Yeah. Can everybody hear me?
Yes, we
hear
can.
you.
Okay. See
Yes.
if I'm now sharing. Am I sharing the screen?
Yes. Roger.
See to make it bigger. Oh, no, yeah. Yeah, so thanks for inviting me to the seminar. I got the opportunity to be part of the first EuroMoon mission, EuroMoonMars mission to Hawaii, and to be part of a simulation. And I also did my own research there. So my research was about the secondary mineralization in lava tubes. And the main goals of the first mission at high seas, which is on the northeast flank of Mauna Loa, was to do some geological field activities and to test the equipment there, because it was also the first time for the EuroMoonMars campaign, and to make the protocols about the new testing equipment. It was also the first moon simulation, and it was a multidisciplinary project with a lot of institutes, what brought up an international crew. And a main part was also some lava tube exploring. So why are lava tubes important? Because they're also very commonly present on Moon and Mars. So if I pick my laser, here on the right, if you can see the red dot, you can see a lava tube on Mars where the ceilings sometimes are collapsed. So you see the whole line of the lava tube with all the skylights, and you can see them on Hawaii as well, where you can also see all the skylights. And the lava tubes, such on Mars, are important because they provide stable conditions, such as a stable temperature and also protection from solar radiation. And there are no dust storms there, so it provides stable environments for all kinds of processes. And in those lava tube, secondary deposits form from the basaltic rock, and those provide insights on the conditions and processes that play a role in the subsurface. So if we do research on those kind of deposits here on Earth, it can already tell a lot about those kind of processes on other planetary bodies. And also microbial processes could play a role in the formation of these kind of deposits. And analytical methods used in this study can also be brought with future missions, such as the Rover Perseverance or other drones or rovers. So try to get to the next slide. Yes. Okay. So the methods used here in this study is mapping and taking field samples. So we did some lava tube exploring and took samples from the deposits we found in those lava tubes. And back at home, we applied infrared spectroscopy, and that can already tell a lot about the chemical bonds in those deposits, mineral identification, and it can also be used for remote sensing. And those kind of techniques can also be applied to rovers. And we did also some chemical analysis. So here you can see a map of the vicinity of high seas here on the north flank of Mauna Loa. And you can see the squares with the numbers are the sampled locations, with the green dots are the skylights. And basically in the area, you have three main lava tube systems that are sometimes broken up into segments. And from the right to the left here, you can see it in the geological map. It goes from older lava tube to younger. So the oldest lava tube is already existing for thousands of years. The middle one is hundreds of years, and to the left, it's a lava tube that's not even a century old. So what do we find in those lava tubes? Basically 3 different types of deposits. Those are the white powders, also named space cocaine, because they really look like it. And you can also find them in their more crystallized form. Then you have some crystalline crusts that formed on the ceilings and the walls of all those lava tubes that look like these large patches of green botryoidal patches, but also sometimes more crystallized in the cracks of basaltic rocks. And then you have some coralloid speleothems, and those are called like that because they represent more like coral-like features, also popcorn-like. You can also find them on lava stalactites in those lava tubes. So, of which and they are already present in all the caves. Doesn't matter how old they already form pretty quickly and also in large quantities. So what do they consist of? Well, most of them are hydrous minerals, so they bear a lot of water into their in the crystal lattice, and you can already see the water components in the spectra, but also carbonate, silica, and sulfate. So basically, the white powders consist of tannadite or mirabilite that are sodium sulfates. Gypsum are composed of the crystalline crusts. So the crystalline crust consists purely out of gypsum. And here's a wavelength map of those gypsum crusts on basaltic rocks. And if you use infrared spectroscopy, you can already see pretty quickly that all the highlighted areas are at different wavelengths already show how quickly the secondary mineralization is seen on the basaltic surface. And each spectra is also very correlate with their own different kind of mineralogies. So you have the tannadites, the gypsum, and also the opal and calcite. Those are the speleothems, consisting of an hydrous form of quartz and calcite. And those coralloid speleothems consist of alternating layers of silica and also calcite. So how do these minerals form? Well, the hydrous variations tell us that they form by hydrological processes, and those break down the basaltic rocks inside the lava tubes, and the breakdown of basalt therefore supplies nutrients that can be used for the secondary mineralization. Also, the sulfate and the carbonate in the minerals can be supplied by either soil formation or oxidation reduction processes of bacteria that are living inside those rocks. And basically the meteoric water, so rainwater, takes up all those kind of nutrients, takes it into the lava tube, and their evaporation leads to the formation of those kind of minerals. Oh, too far. And when we look at the coralloid speleothems, the alternation of the layers could be due to pH changes, due to seasonal variability of the rainwater present in the area. And when the pH decreases, you can have the opal precipitation, so the darker layers. And when the pH increases again, you get the calcite layers. So if we also want to look at the if there is microbioactivity, then we have to look at the coralloid speleothems, because a lot of these minerals that are also formed in other volcanic caves mostly contributed to microbioactivity. And if you look at spectra from this study, it looks very similar to biogenic silica of other studies. Also, in the cavities of those speleothems, you can find nanoglobules. There are kind of round particles that are left behind by microbes. And also, I found some nitrogen in some of these samples, which indicate that nitrogen fixation bacteria use those nitrogen from the cave atmosphere to incorporate into the structure of those minerals. So basically, the microbial films can catch up the silica, form the opal layers. And also the cavities provide microenvironments for those bacteria in which they can regulate their own pH and therefore also can lead to the cyclicity of those layers. So how does that compare to Mars? Well, the basalt found near high seas is very similar to the basalt found on Mars, with a lot of anortite, which is a mineral which has a lot of calcium that can provide for the gypsum and the calcite of those minerals. It also has very dry conditions which preserve those minerals. So these kind of minerals can also be really pristine in the lava tubes on Mars. And basically, remote sensing already showed that there is a lot of gypsum, opal, and calcite present on the surface of Mars. And lava tubes are abundantly present on the surface. So the same kind of processes play a role on Mars as well. So therefore, it could be easily also in the subsurface. So when we use future missions to explore those lava tubes, it could be very well that the same kind of minerals and that we found at Hawaii could be present there as well. So that already tells a lot about the kind of processes that play a role in the subsurface of Mars. So to conclude is that the main minerals are sodium sulfates, gypsums, and opal and calcite speleothems. And those form as interaction between basalt and water. These kind of processes play a role on Mars as well. So it's a good analog. And therefore we can also seek for signs of life in the subsurface of Mars. And the methods that we used here can also be applied to rovers, and therefore you can easily find the kind of mineral phases and processes that you that are present in the subsurface of Mars. So hereby I end my presentation. Thank you very much for listening. If you want to be part of the next missions, you can also contact either Bernard or Michaela. And I also want to tell some more about the radio interview that's coming up with Anne Lot and I. That's on the 17th of August, and then we tell a little bit about the simulation and the mission that we did on Hawaii. And also, if you want to see a little bit more drone images of the mission, you can check a video I made that's called High Above the Seas on YouTube to look how it is to do a simulation like that. Well, thank you very much for your time.
Yeah, super, amazing.
Thank you, Sebastian.
Yeah, we have learned a lot, a good, excellent progress.
Yeah, now I have to
just a small question on so microbial activity. So we're able to identify what type of microbes are doing this different type of biomineralization. So are they ancient bacteria? Is there a large diversity? And is that something that could be envisaged for Mars?
Thank you very much. It's a good question. Here on Earth, there's a lot of variety in microbes that are present inside those lava tubes. Well, we took the samples of inside the lava tube so that anaerobic bacteria play a large role, and that could be as well on Mars. And these kind of bacteria can use oxidation or reducing processes, so they don't use oxygen or photosynthesis. So they could be present on Mars as well. And therefore they can use the minerals that you find in those basaltic rocks to form this kind of precipitates. And also, so basically, if you go to Mars and if you look at early Mars, there was already liquid water present there. And on Earth, life is extremely robust and lives in all kinds of places and evolved pretty quickly. So on early Mars, life could have developed pretty early as well, and therefore could traces of those microbes could have been preserved in these kind of deposits in the subsurface of Mars. So basically, if you want to look at the kind of microbes that you want to find on Mars, you have to look at anaerobic conditions in which they use minerals and maybe movement of water to make these precipitates.
Excellent. And also, so going to some lava tubes on Mars, so that would contain ice, that would contain organics. then eventually some other forms of living organism, you could find a way to diagnose there. So we have to find, we have found a number of lava tubes on Mars, on the Moon as well, and even some entrance of them. So these are a very good target for future exploration.
Yeah, it would be pretty interesting to send some future rovers inside those lava tubes and find those minerals. Can already tell a lot about yeah, what is going on there, and also what means it can provide for humans to live there.
Yes, must be chilly there,
yeah.
But that's a place where we want to do, and that's a transition to the next talk on the chill ice. Sabrina?
Nice,
exactly. So EuroMoonMars is at the moment planning a really interesting project that's actually going to happen inside a lava tube on Iceland, and it's called the Chill Ice Mission. Telling us more about will be Mark Himskerk. He's an exogeologist from the VU Amsterdam and specializing in in-situ resource utilization from the Moon and Mars, of course. So with this latest EuroMoonMars project, the Chill Ice Mission, we aim to build an analog habitat inside a lava tube on Iceland. Mark, can you tell us a bit about this mission and what has been happening?
Yes, of course. So the mission, it is called Chill Ice. It stands for the construction of a habitat inside a lunar analog lava tube. And it's the Iceland campaign of EuroMoonMars. Let's see, does it work to go to the next slide? Yes. So a short introduction to our team. I think some of our members here are actually present in this Zoom call as well. So we have Bernard as our mission advisor. I will be the head of subsurface operations. Charlotte Powell is the head of logistics. Sabrina, of course, you're also on the project. And we also have a support team of engineers and radiophysicists. So actually, a small month ago, we were in Iceland with a small team of us to do some scouting over there to see if we could find a suitable habitat or habitat location. So a nice lava tube. And we also made some first connections with some political parties, local parties within the university, at City Hall, and with members of parliament. So in very brief terms, the mission of Chill Ice, it is to construct an analog habitat while being in simulation. This means that the whole setup of the habitat will take place by astronauts wearing astronaut suits and therefore also being limited in their movements, in their fine motorics, and also in their vision. And of course, it will be inside a lava tube. And this is a preparation for lunar and Martian missions. Well, I think Sebastian already introduced us a lot as to why we want to go into the subsurface. One of the main economical aspects has to do with the transportation. Each kilogram that you want to transport to the moon is about 1 million euros. And if you want to do it to Mars, it's going to be even more costly than that. But you still need the protection from the radiation. You need the isolation for the thermal aspects. You need to protect yourself from the regolith, so the very fine dust that you can find on both the Moon and Mars. You want to protect yourself from micrometeorites. This is a very big problem because they can be as small as a grain of sand, but if they're moving with 20 or 40 kilometers per second, they will puncture your walls unless you have a very rigid structure. And it is this structure that we will need to protect the humans. So in terms of efficiency, in terms of safety, and also for quick readiness, it is very important to get inside a lava tube. And as Sebastian already told us, it's also very important to do the research. You can do in situ research utilization inside the lava tube. You can use rocks, and the rocks, they are stored in a pristine environment. So if there has been life on Mars, I totally agree with Sebastian. It will be maybe as fossils, but it will be present then inside those lava tubes. So a very brief introduction. We've been talking a lot about lava tubes, but maybe not everybody knows how they formed exactly. So lava tubes, they form when you have a very liquid flow of lava flowing around on the surface. The outside is very cool, so it cools off and it solidifies on the outside, which forms a solid crust, while the lava itself is still flowing on the inside. Eventually, the lava will dissipate. It will end up in the flow somewhere down the road, and you will end up with a hollow tube. And eventually, of course, you can live inside that tube. So this is what the lava tube that we were in Iceland looks like. This is an aerial view over here. I'm not sure if you can see the mouse. This is the Stefan Settler lava tube, and this is all located in a very big lava flow. It's called Hattemunderföhn. And over here you can see the entrance to a very big gallery in the east side of the system. And this is also where we will build our habitat. And on the inside it looks a bit like this. It's about 15 meters wide and almost 70 meters long. So it is indeed very suited place to construct a pretty large habitat in there as well. So in short, the mission objectives, first of all, of course, to discover suitable lava tubes and to conduct research on the settlement habitability and to improve our international collaborations. Within Iceland, we are helping the Space Iceland to set up a national space office as well. And the eventual mission in which we will build our habitat will take place in May 2021. And we have set some boundary conditions for astronauts, looking also to the Apollo missions when they were on the moon. So they will have approximately 8 hours of oxygen, or at least we will give them 8 hours. And in that time, they will have to unload the habitat from the rocket. They have to bring it inside the lava tube, set it up there and make sure it's habitable and that they can survive in there. We will do a very short simulation mission of only 2 days. It's just to give a proof of concept that we can and that we want to live indeed inside the lava tube. So the mission, we will of course focus on the exploration of lava tubes here on Earth, but also on the moon, on Mars. We will develop new technologies such as an inflatable habitat. There's a strong focus on human well-being. How can you survive in extreme environments? And this is also applicable for the Earth. How can we help humans on Earth survive? And of course, we want to help in the preparation for settlement so that we can later on colonize the solar system, or at least Mars and the moon. So if you want to get in contact with us, you can via email, via LinkedIn, and of course also via EuroMoonMars. And we are on Instagram, we're on Facebook, we're also on LinkedIn. And yeah, thank you for your attention.
Thank you, Mark, for that very short introduction. Yeah, I'm looking forward to the mission, and we'll also be posting updates on our social media pages regularly for those who want to keep up to date with us. So actually, this is a really good point to lead to our very last speaker, because once we enable humans to live on Mars, what we need there is a culture. It's a kind of society. And Elizaveta Glukova is a graphic designer and media artist from Russia. She graduated from the Royal Academy of Art in The Hague and runs a graphic design practice. Elizaveta is also the curator of the Moon Gallery project. However, today she's going to tell us a bit about the importance of bringing culture to the Mars, of bringing a society there, and of how we try to do this with the EuroMoonMars community.
Actually, in Iceland, we plan also to bring some art activities, and so we are discussing as well with artists. At the same time, we bring geologists, scientists, engineers. We will also bring artists and a large community.
Can you see my screen?
Yes, we saw it before. Yeah.
Good. Hello, everyone. So while we are all fascinated by development of technology sorry?
We saw it before, and then it...
You don't see it now?
It's dark now.
You can only see a black page.
Huh. Okay.
It's dark now. But just before we saw something.
I will try to do it again then.
Mm-hmm. Yeah,
yes,
now
we see it.
Okay. Then I leave it like that.
Yeah, okay, perfect.
So, back to my talk. So while we're all fascinated by development of technology that allow us today to send missions to Mars, I would like to offer another perspective on space exploration. Space is known as a very challenging environment where only scientists and engineers get to operate. However, in the EuroMoonMars collective, we believe that for us to become a truly interplanetary species, the cultural aspect has to be involved. EuroMoonMars program, which I coordinate together with Bernard Foying and Anna Sitnikova, offers a platform for the most exciting cooperation between space scientists, engineers, artists, designers, and society at large. We support various initiatives connecting art and Moon and Mars and beyond. We organize meetings, workshops, art, science, space classes, and projects at various universities, sessions at international conferences, art exhibitions, musical and visual performances. So here you can see on the slides some of the documentation from workshops. Together with the members of the EuroMoonMars team, we are wondering, what would be our new values and ideas? What would be new aesthetics in the space, also taking account lessons learned here on Earth? How, for example, dance or sculpture or architecture would function in different gravitational conditions, and how our perception of beauty will change while our bodies will be adapting to the new environment. How would we perceive colors without atmosphere or with a very different atmosphere, and which new art forms will sprout in such a different context that space can offer us? So before trying to answer all of those exciting questions, I would like to make a few examples of the artworks that were designed to space and actually sent to space. So here is one of the most recent examples of the artwork, which was not just designed for space, but also built in space. It's an artwork by Eduardo Katz, and at the moment it's aboard of the International Space Station. The title of the artwork is The Inner Telescope, and it was realized by the French astronaut Thomas Pesquet on Saturday, February 18th in 2017. So this work was especially created for the zero gravity conditions. And also it was created from materials that already existed on the station. It consists of a form that has neither top or bottom, front or back. And this kind of makes sense because in the zero gravity, those values are not so important anymore. It can be viewed from many angles, but from one of them, you can read a French word, moi, meaning me or myself. And from another point of view, you can see a human figure with its umbilical cord cut. This moi stands for collective self, evoking humanity, and the umbilical cord cut represents our liberation from gravitational limits. Eduardo Katz has been theorizing and producing artwork and poetry that challenges the limits of gravity since 1980s. And now, finally, after more than 30 years, his piece can be exhibited in the proper conditions. Another example of space art is a fallen astronaut. That's a work exhibited on the moon. It was brought there by Apollo 15 mission. Actually, it was brought there in secret, and its presence there was revealed only after the mission was over. Fallen Astronaut is a 3.5-inch aluminum sculpture created by Paul van Hooydonk. It's a small figure which symbolizes an astronaut in a spacesuit, and it's a symbol of all sacrifices made for the advancement of space exploration. So this piece was commissioned by Apollo 15 team, and next to the sculpture you can see a list of 14 men who known to die during the space race. But going back to the Mars, did you know that there is already artwork on the Mars? Maybe you heard about the British artist Damien Hirst. He is famous for his spot paintings, which are rows of random colored circles. So this is his piece, and it's exhibited on Mars. It's called Calibration Target for a Bagel to Mars Lander, British Space Mission. As you might guess, that's not only artwork, but it's also an instrument which is made for a calibration of instruments and cameras installed on the rover. The piece is made from aluminum and natural pigments, which in the art world known as Mars pigments, which makes a lot of sense because, of course, the cameras have to be calibrated to the colors that can be found and identified on the surface of the planet. It's a great example of collaboration between art and science and engineering. So one might wonder, why should we spend our effort on the culture and art for space while there is still so many technical challenges laying between present moment and the time when human will be freely operating beyond the Earth planet? It is a fair question, and of course, there is still a lot to be done to guarantee human survival, for example, on Mars, as our bodies are not suitable for the natural conditions of this planet. But when we talk about colonization of the planet, I think it's important to realize that guarantee of the survival will only be a part of success. Once the basic quality of life can be guaranteed, like oxygen, water, and bearable temperature levels, and etc., human will start developing other needs, such as a need for certainty and comfort, need for variety, need for significance, need for freedom, diversity, spirituality, and need for creativity at the end. And all those things, they cannot be provided by science and technology. And those needs can be only guaranteed by development of new culture that would be corresponding to new environments. That's why at the EuroMoonMars collective, we put the best of our efforts into envisioning the future of interplanetary culture, as we believe that culture makes a distinction between mere survival and life. And at the moment, one of the biggest projects of the EuroMoonMars collective is a moon gallery. It's going to be a permanent museum on the moon, where we ask artists to think about what are the ideas they want to promote into the future, and what are the ideas they want to leave behind. That's a miniature gallery, but after that, we also want to go beyond and to see what kind of culture can be developed on Mars. Thank you very much for your attention. And if you have any questions, you can contact us at art@moongallery.eu.
Thank you, Elisa. One question is, how can people, how could our viewers, for example, get involved in EuroMoonMars?
Oh, there are actually several ways to do that. Of course, they can become an artist at the Moon Gallery. That's one of the ways. They can participate in our workshops, which are updated at the moongallery.eu website. This is a workshops which involve collaborations between artists, engineers, designers, etc. They can also, for example, propose to have a workshop at their location. So they can invite us to come, and then we would be glad to organize a workshop at their institution.
Mm-hmm. Okay, that sounds really interesting.
Yeah, and this is already possible now, even in times of COVID pandemics. We have had a number of sessions remotely. We had a nice session in Padova. We wanted to go there, but finally we did it virtually. So we can also organize some EuroMoonMars session all over our world virtually. But we hope also that we will have also a number of events, and we were able also during the pandemics to be among the first to be authorized to open an exhibition. So this was done in the glass house in the Amstel Park in Amsterdam for the Moon Gallery Garden. But we are also planning some events in Leiden, for instance, together with a Moon Mars workshop on 12-13 September. We'll have also a reopening of a Moon Gallery observatory event there.
Yes, everyone is welcome to join us in Leiden. We hope it will be a great event